In this video, we demonstrate a multi-touch display based on frustrated total internal reflection that works even in the presence of ambient daylight. We achieve this robustness at almost no extra cost by continuously capturing reference images. Here you see several users interacting with the device. At this point, we have switched on the room lights. Note that the scene is significantly brighter, but that the video camera automatically compensates for this effect. Now we open the curtain so that ambient daylight illuminates the display. The scene was captured in the afternoon of an overcast day. Despite the clouds, daylight consists of a wide spectrum of wavelengths, including infrared, which we use for the detection of touch points. Our idea is to continuously capture referenced frames to compensate for the ambient infrared light that is reflected by objects close to the touch panel. In fact, we capture reference images and images showing the touch events in an alternating fashion. Here you see the raw camera output. The standard way to cope with ambient illumination is capturing a reference image before interaction starts, and then subtracting this image from the captured frames during interaction. Note that when we open the curtain, the hands start to become visible because they reflect ambient light into the camera. When we threshold the images, the touch points are clearly visible. As we open the curtain, the image gets noisy, and an automatic real-time differentiation of touch events from spurious events becomes very difficult. This is why we continuously capture reference images by switching the illumination on and off. Here we show only the reference frames, which we identify by 4 LEDs in the corners of the panel. Taking the difference, as shown here, compensates for effects that cause changes in the ambient illumination and yields clearly visible touch events, even as the curtain is opened and the amount of ambient infrared illumination increases. Applying a threshold to these images shows that even in the presence of daylight, the touch events are still identifiable. A comparison of the standard approach and our approach based on continuously capturing reference images clearly shows the improvement.